Hello everyone, today I'm going to talk about static friction. Have you ever thought, how do we walk? When we walk, we push the floor backward and the floor pushes us forward. What is the source of this forward force from the floor? Any ideas? Let me give you a hint. I put some oil on the surface. You agree that the walking would be more challenging, right? What changed here? That's true, the friction is smaller when you put some oil on the surface, right? Another example. So the friction force is the source of the force that the floor is giving to your foot. Another example. I have a brick here, and I want to push the brick with some amount of force. You see the brick is not moving, but I'm pushing the brick along the surface. Let's see what's happening via the free body diagram. The surface is here, and I put the object on the surface. My coordinate system are this. And I know the object is not moving. It's constant. It's static. The velocity is constant, and acceleration would be zero. A zero acceleration via the Newton's law of motion tells me total force is zero. And total force is a vector. So along the x-axis and y-axis, total force is zero. I know that the object is pushed by a force along the positive x-axis. For y-axis, I know I have weight downward and normal force upward. The normal force cancels weight. But what is canceling pushing force here? Static friction. In the x direction, total force is zero, so push force is cancelled by a static friction. And I can calculate static friction force by this equation that is equal to pushing force in magnitude, but in direction they are opposite direction. Okay. Another example, or let's continue with the brake example actually. If I keep increasing the amount of force on the brake, at some point the brake starts to move. After the movement, there is no stationary case anymore. So a static friction has an upper boundary, has a maximum. When the object starts to move. Okay, this maximum static friction is determined by two factors. One is the physical properties of two surfaces. If the surfaces are rough, they can grip each other better, the maximum static friction is larger. Instead of the brake, if I use the book, I need a smaller force for starting the movement. So that means smooth surfaces give me a smaller maximum static friction. This quantity is encapsulated in a static friction coefficient. That is between 0 and 1. Two very slippery surfaces have mu as closer to 0, and two very gripped surfaces have mu as close to 1. If I push the brake downward, I'm increasing actually the normal force. Then I need more force to start the movement. So another factor that is important here is normal force. So maximum static friction is equal to mu s, which is a constant times normal force. Okay? Now let's go for another example. This is a surface that I can increase its inclination. If I continue inclination of the surface, eventually at some angle, the brick starts to move. I measured the angle before, and that was 40 degrees. Okay. I want to know, can I measure or calculate the static friction coefficient knowing this angle or not? This angle is special because this is the angle that if I increase it by a little bit more, the object starts to move. So for this angle, I have maximum static friction force. Okay? This is the diagram for the brake on inclined surface. Okay? The angle is 40 degrees. My coordinate system is like this. Okay? What forces do I have here? Weight is downward. Normal force, normal to the surface, and the static friction is holding the object, is not letting the object slide down. So it's upward. But it is maximum static friction because it's about to move, okay? Let's write down force along the x-axis. For the x-axis, or x direction, I have this maximum static friction and x component of weight. So weight can be decomposed to two components along the y-axis and the x-axis. And if this is 40 degrees, this angle is 40 degrees too, okay? For the x direction, I have Wx, which is positive, and maximum static friction, which is upward. But remember, maximum static friction can be calculated by mu s times normal force. So I write that down. And I know it's 0 because the object is not moving, right? For y direction, I have normal force upward and y direction, y component of weight down. This is equal to 0. If I rearrange these two equations, I will have this. W in the weight in the x direction is equal to mu s n, normal force. And normal force, if I just rearrange this second equation, I will get weight along the y-axis is equal normal force. By dividing these two equations, I get weight along the x-axis divided by weight along the y-axis is equal mu s, because these two n cancel out each other. But what is this? Do you remember, guys, that x component of a vector divided by y component of that, what would be that? That is tangent, okay? So, tangent of theta slide would be equal to a static friction coefficient. So by calculating tangent of 40 degrees, you can get mu s. And tangent of 40 degrees is equal 0.84. So mu s is 0.84, which is unitless. Any questions? Okay, so just to review, we always use total force equals 0 because there is this static state. The object is not moving. And that's the key point. And for maximum static friction, we have mu s times n. Okay? Thank you.